Good evening, fellow Skywatchers. I'm Atlas Reid, and welcome to the Nocturnal Astronomer, your companion for peaceful celestial explorations. Tonight, we turn our attention to one of autumn's most captivating spectacles, the hunter's moon. This October full moon has illuminated the harvest season for countless generations, carrying with it centuries of tradition, astronomical significance, and a beauty that continues to draw our eyes skyward. We'll explore why this particular moon earned its evocative name, how it relates to the harvest moon that precedes it, and what makes its timing so special in the dance between Earth and our celestial companion. We'll discover the science behind supermoons, understand the fascinating optical tricks our minds play when we see the moon near the horizon, and learn how ancient farmers relied on this bright beacon to complete their work before winter's arrival. Whether you're here to drift peacefully into sleep or simply enjoy some background knowledge about our universe, tonight's journey promises to illuminate the wonders of October's full moon. If you enjoy these explorations of the night sky, please consider giving this video a thumbs up and subscribing to the Nocturnal Astronomer. And hey, where were you the last time you saw a full moon? Let me know in the comments below. Alright, let's dive in. The name Hunter's Moon has graced October's full moon for centuries, carrying with it the essence of autumn's turning and humanity's age-old relationship with the changing seasons. First appearing in written form during the early 1700s, this name speaks to a practical reality that our ancestors knew intimately. October marked the beginning of hunting season across much of the northern hemisphere, and the bright moonlight that bathed the landscape during these nights became an invaluable tool for those preparing for winter. The logic behind this timing becomes clear when we consider the agricultural calendar. After the harvest season concluded, usually marked by the harvest moon in September, the fields lay bare and stubble covered. Animals that had fattened themselves on summer's abundance, particularly deer, turkeys, and pheasants, ventured out to scavenge any remaining crops. With the leaves falling from the trees and brush thinning in the cooler weather, these game animals became far more visible than they had been during the lush summer months. The bright moonlight extending into the evening hours allowed hunters to track and pursue their quarry more easily, building up stores of preserved meat for the long winter ahead. But hunting game wasn't the only pursuit associated with this moon. In Anglo-Saxon regions, October historically initiated fox hunting expeditions. The fallen leaves and open fields provided ideal conditions for spotting and pursuing foxes across the countryside. Though fox hunting has largely disappeared as a sport in modern times, its historical connection to October's full moon remains embedded in the folklore and traditions that surround this celestial event. The hunter's moon designation appears across numerous cultures, though with slight variations. The Stockbridge-Munsee tribe of Wisconsin and the Tunica tribe of Louisiana referred to it as the hunting moon, emphasizing the action rather than the person performing it. Yet the connection remains unmistakable. In medieval English, pagan, and Wiccan traditions, October's full moon carried another evocative name, the blood moon or sanguine moon. This dramatic title referenced both the hunting season's bloody nature and the deep red hues that autumn leaves painted across the landscape. The relationship between the hunter's moon and its predecessor, the harvest moon, follows a specific astronomical rule rather than being tied to any particular calendar month. The harvest moon is always the full moon that occurs closest to the autumnal equinox, which typically falls around September 22nd or 23rd. Whichever full moon comes next in the lunar cycle receives the title of hunter's moon. This means that depending on how the lunar phases align with our calendar, the harvest moon can appear in either September or October. When it falls in September, as it most commonly does, October claims the hunter's moon. But in years when October's full moon sits closer to the equinox, that October moon becomes the harvest moon, and the hunter's moon shifts to November. This flexibility in timing can seem confusing at first, much like trying to predict whether a particular year will have 13 full moons instead of 12. Think of it this way. Imagine you're planning to meet a friend at a coffee shop closest to the library. Most days, that might be the shop on Main Street. But if the library happens to be on the other side of town that day, you'd meet at a different coffee shop entirely. The principle remains the same, closest to the reference point, even if the location changes. The harvest moon and hunter's moon follow this same logic, always defined by their relationship to the autumn equinox rather than locked to specific dates on the calendar. Understanding these naming traditions connects us to centuries of observers who watch these same lunar phases, marking time and season by the moon's reliable cycle through the sky. When we hear the term supermoon, it conjures images of an enormous lunar disk dominating the sky, seemingly close enough to touch. But what exactly makes a supermoon super, and how significant is this celestial geometry? The answer lies in the shape of the moon's orbit around Earth, a path that proves far more interesting than a simple circle. The moon traces an elliptical orbit around our planet, resembling an elongated circle or a gently stretched oval. Because of this elliptical shape, the distance between Earth and Moon varies considerably throughout each monthly orbit. When the Moon reaches its closest point to Earth, approximately 226,000 miles away, astronomers call this position perigee. At the opposite end of its orbit, when the Moon swings out to roughly 251,000 miles from Earth, it reaches apogee, its farthest point. Every 27 days or so, as the Moon completes one orbit, it passes through both perigee and apogee. These points don't align with any particular lunar phase by default. The Moon could be new, full, or anywhere in between when it reaches either extreme of its orbit. A supermoon occurs when the full moon phase happens to coincide with the Moon being at or very near perigee. When these two events align, the Moon appears noticeably larger and brighter than an average full moon, though the difference is more subtle than popular media might suggest. The term supermoon itself lacks official astronomical standing. Scientists prefer the more technical phrase perigee-syzygy, where syzygy describes the alignment of three celestial bodies, in this case, the Sun, Earth, and Moon. The word supermoon was actually coined by an astrologer named Richard Nowell in 1979. He defined it somewhat arbitrarily as any full or new moon occurring when the Moon comes within 90% of its closest possible approach to Earth. While astronomers might prefer more precise terminology, supermoon has captured the public imagination and become the common way we describe these events. So how much bigger and brighter does a supermoon actually appear? At its closest perigee, a full moon can look approximately 14% larger in diameter than when it appears at apogee. Think of it like comparing a quarter held at arm's length versus holding it a few inches closer to your eye. The change is real but subtle. The brightness difference proves more noticeable, with a supermoon appearing roughly 30% brighter than a full moon at apogee. This increased brightness comes from a straightforward principle. The closer the light source, the more light reaches your eyes, following what physicists call the inverse square law. Despite these measurable differences, actually detecting a supermoon with the naked eye presents a challenge. Without a reference point for comparison, most people cannot tell whether they're looking at a supermoon or an ordinary full moon. We don't carry around mental templates precise enough to distinguish a 14% size difference in an isolated object in the sky. This is why photographs comparing perigee and apogee moons, placed side by side, prove so striking. They give us the comparison our eyes alone cannot make. Supermoons occur relatively frequently, appearing 3 to 4 times per year, and they always arrive consecutively. This happens because of the way the lunar cycle synchronizes with the moon's orbital position. During most of Earth's orbit around the sun, the timing of full moons and perigee don't overlap. But when they do align, they tend to stay aligned for several consecutive months before drifting apart again. Understanding supermoons helps us appreciate how the moon's motion through space creates these subtle variations in what we see from Earth, even if the dramatic difference we perceive sometimes owes more to other factors we'll explore next. Perhaps the most striking aspect of viewing any full moon, super or otherwise, occurs when we catch it rising near the horizon. At that moment, the moon can appear absolutely enormous, a giant golden disk that seems to dwarf its appearance later in the night when it rides high overhead. This dramatic size change feels so obvious, so visceral, that it shocks most people to learn the truth: the moon's size hasn't changed at all. What you're experiencing is called the moon illusion, one of the oldest and most persistent tricks our brains play on us. The moon illusion has puzzled observers since at least the 4th century before the Common Era, when the Greek philosopher Aristotle noted how much larger the moon appeared near the horizon compared to when viewed overhead. For centuries, people attributed this effect to Earth's atmosphere acting as a magnifying glass, bending and enlarging the moon's image. While our atmosphere does affect the moon's color, making it appear more orange or red when near the horizon due to light scattering, it actually makes the moon slightly smaller, not larger, due to refraction effects. The atmosphere explanation doesn't hold up to scrutiny. So what causes this powerful illusion? Here's where things get fascinating. Scientists still don't have complete consensus on the answer. Despite hundreds of research papers and numerous theories, the moon illusion remains incompletely explained. However, several leading theories help us understand what might be happening in our visual processing system. One popular explanation involves our perception of the sky's shape. Rather than perceiving the sky as a perfect dome or hemisphere above us, our brains seem to interpret it as a flattened dome, somewhat like an upturned bowl that's been gently pressed down. When the moon hangs near the horizon, our visual system places it against this flattened dome model at what seems like a greater distance than when the moon appears overhead. According to a principle called Emmert's law, if two objects cast the same size image on our retina but we perceive one as being farther away, our brain interprets the more distant object as being larger. Think of it like seeing two people standing on a hill, one near you and one far away. If they appear the same size to your eye, your brain knows the distant person must actually be much taller. Another theory points to the presence of reference objects. When the moon rises near the horizon, we see it in context with trees, buildings, mountains, and other familiar objects that we know are large. This context might trick our visual system into scaling up the moon's perceived size. When the moon floats high in an empty sky with no reference points, this scaling effect disappears. This explanation relates to a well-known optical illusion called the Ebbinghaus illusion, where identical circles appear different in size depending on whether they're surrounded by smaller or larger circles. You can test the moon illusion's nature quite easily. When you observe a huge-looking moon near the horizon, try this simple experiment. Extend your arm and compare the moon's size to your thumbnail. You'll find your thumbnail covers it nicely. Later, when the moon has climbed high and appears smaller to your eyes, extend your arm again. Surprisingly, your thumbnail still covers it just the same. The moon hasn't changed size at all. The rising moon actually sits slightly farther from you than the overhead moon because you're looking across Earth's radius, about 4,000 miles, but this tiny distance difference works opposite to the illusion, making the rising moon technically smaller, not larger. The moon illusion reminds us that perception isn't simply seeing what's there. Our brains actively construct our visual experience, and sometimes those constructions diverge from physical reality in fascinating ways. To fully appreciate the hunter's moon, we must first understand its close companion, the harvest moon, because these two lunar events share a special relationship rooted in both astronomy and agricultural tradition. The harvest moon represents one of the most well-known full moon names of the year, immortalized in songs, festivals, and folklore across numerous cultures. Its fame stems not just from its evocative name, but from a genuine astronomical phenomenon that made it invaluable to farmers throughout history. The harvest moon designates the full moon occurring nearest to the autumnal equinox, that moment around September 22nd when day and night achieve roughly equal length and autumn begins in the northern hemisphere. What makes the harvest moon astronomically special relates to how it rises from one evening to the next. Normally, the moon rises approximately 50 minutes later each successive night as it orbits Earth. This regular delay means that if the moon rises at 7 o'clock one evening, it will rise around 7:50 the following evening, and so forth. But during the period around the harvest moon, something different happens. The delay between successive moonrises shrinks dramatically, sometimes to as little as 20 to 25 minutes, depending on your latitude. Think of it like a commuter train that usually runs every 50 minutes but temporarily switches to an express schedule, arriving every 20 minutes instead. For several nights surrounding the harvest moon, you get these closely spaced moonrises, each occurring shortly after sunset. This astronomical quirk happens because of the angle at which the moon's orbital path, which roughly follows the ecliptic, meets the eastern horizon during this time of year. Near the autumn equinox in the northern hemisphere, the ecliptic makes a shallow angle with the horizon. The moon's nightly eastward motion along this shallow angled path carries it more northward than upward relative to the horizon, so it takes less additional Earth rotation to bring the moon back above the horizon the next evening. For farmers working to bring in their harvest before frost and winter arrived, these consecutive evenings of bright moonlight extending into the night proved invaluable. They could continue harvesting by moonlight for several nights in succession, each night's moon rising soon after sunset without a long gap of darkness. This practical benefit gave the harvest moon its name and its prominent place in agricultural tradition. The hunter's moon, appearing in the lunar cycle immediately after the harvest moon, exhibits this same moonrise behavior to a slightly lesser degree. While not as pronounced as during the harvest moon itself, the shortened delays between successive moonrises continue through the hunter's moon period. This extended moonlight benefited hunters just as it had helped farmers. The bright moon illuminating newly bare fields and thinning forests allowed hunters to spot game more easily during the critical period when they needed to secure meat stores for winter. In 2025, the timing worked out such that October's full moon on October 6th fell closer to the September 22nd equinox than September's full moon did. September's full moon occurred on September 7th, 15 days before the equinox, while October's full moon arrived only about 14 days after it. This made October's moon the harvest moon for 2025, with the hunter's moon shifting to November. This flip-flop happens roughly every 3 years, demonstrating how the lunar cycle and calendar month don't align perfectly. The astronomical mechanics creating the harvest moon phenomenon work identically in the southern hemisphere, but occurring around the March equinox instead. For observers in countries like Australia, Argentina, and South Africa, their harvest season and special full moon relationship arrives during their autumn, which corresponds to our northern hemisphere spring. The same shallow ecliptic angle that gives us the harvest moon effect in September gives them theirs in March. When October's full moon rises, Whether we call it the hunter's moon or, as in 2025, the harvest moon, it occupies a specific region of the celestial sphere that gives it unique characteristics compared to full moons in other months. Understanding where the moon appears in the sky during October helps us appreciate what makes this particular full moon special from an observational perspective. A full moon occurs when Earth sits directly between the Sun and Moon, with all three bodies roughly aligned. Because of this geometry, full moons always rise around sunset and set around sunrise. The Sun and Moon occupy opposite positions in the sky during full moon, which is why we see the moon's face fully illuminated. It faces directly toward the Sun with Earth in the middle catching the view. During October in the Northern Hemisphere, the Sun rides lower in the southern sky than it did during summer months, following its path toward the winter solstice. The full moon, being opposite the Sun, correspondingly rides higher and spends more time above the horizon. Think of it like two children on opposite ends of a seesaw. When one goes down, the other goes up. As the Sun sinks lower in the sky through autumn and winter, the full moon climbs higher and stays visible longer. October's full moon traces a path across the sky that will look familiar to anyone who remembers watching the summer sun. The full moon follows roughly the same arc the Sun traveled 6 months earlier, around April. This gives October's full moon a substantial presence in the night sky, dominating the darkness for many hours. For those interested in planetary observations, October 2025 offered an additional treat. The hunter's moon rose near Saturn, which had just passed opposition on September 21st. When a planet reaches opposition, it appears directly opposite the Sun from Earth's perspective, making it visible all night and at its brightest for the year. Saturn's position near the hunter's moon created a beautiful celestial pairing visible to the naked eye. The planet appeared as a bright golden yellow star to the right of the moon as they rose together. For anyone with binoculars or a small telescope, Saturn's position so close to the moon made it easy to locate and observe. Though Saturn's famous rings currently appear edge-on from Earth's viewpoint, making them difficult to see, the planet's moons remain visible through modest optical equipment. In the nights following the full hunter's moon, the moon's path carries it through several notable constellations and near other celestial landmarks. On October 10th, the waning moon passed close to the Pleiades, also known as the Seven Sisters, one of the most recognizable star clusters in the night sky. The Pleiades form a small dipper-shaped group of blue-white stars that catches the eye easily. Seeing the moon near such a prominent deep sky object offers an excellent opportunity for observers to familiarize themselves with this part of the sky, using the moon as a guidepost to find features they might observe again when the moon has moved on and darker skies return. The moon's position in October also carries it through the constellation Aries during the full phase. For those who follow astrological traditions alongside astronomical observation, the moon's passage through Aries connects October's full moon to themes of energy, initiative, and new beginnings, though we focus here on the physical and observable aspects rather than interpretative traditions. The important observational note is that October's full moon climbs high enough and stays up long enough to provide excellent viewing opportunities throughout much of the night, weather permitting. As we watch October's full moon trace its path across the autumn sky, we're observing the same celestial mechanics that have governed these motions for billions of years. While the hunter's moon remains the most widely recognized name for October's full moon in English-speaking regions, numerous cultures throughout history have given this lunar phase names reflecting their own experiences with the season. These alternative names provide windows into how different peoples around the world have observed and marked the passage of time through the lunar cycles. Native American tribes across the North American continent developed sophisticated lunar calendars, with each month's full moon receiving names tied to observable natural phenomena or important seasonal activities. The Anishinaabe people, whose traditional territories span the Great Lakes region, called October's full moon the freezing moon, marking the arrival of the first frosts that signal winter's approach. This name reflects the practical reality of their northern climate, where October brings the cold that transforms the landscape and requires communities to ensure all winter preparations are complete. The Dakota tradition knew this moon as the drying rice moon, referencing the time when harvested wild rice, a crucial food source, needed to be dried and prepared for storage. This preservation process proved essential for surviving winter months when fresh foods became scarce. Similarly, several Ojibwe communities called it the ice moon, another acknowledgement of the freezing temperatures beginning to grip the land. The Haida people of the Pacific Northwest coast used this same name, demonstrating how different cultures in similar climates independently arrived at related observations about October's character. From a different perspective, the Cree people of central Canada named October's moon the migrating moon, drawing attention not to the weather but to the great movements of birds preparing for their southward journey. These mass migrations represent one of nature's most impressive spectacles, with countless waterfowl, raptors, and songbirds streaming across the October skies. For peoples who relied on hunting these birds or simply marked time by their movements, the migration provided an unmistakable signal of the season's turning. Other traditions focused on the botanical changes occurring during October. The Anishinaabe also used the name falling leaves moon in some communities, a poetic acknowledgement of autumn's most visible transformation. The Celtic tradition employed seed fall moon, noting how many plants release their seeds during this period, scattering next year's potential across the landscape before winter arrives. The Cherokee people sometimes called October's moon the Big Chestnut Moon, celebrating the harvest of these nutritious nuts that provided important food stores. The Creek tribe in the southeastern United States used this same name, highlighting the importance of chestnut gathering across multiple cultures. The Apache tribes of the Southern Plains gave October's moon a name that speaks directly to agricultural activity, calling it the moon when corn is taken in. This straightforward designation marks the completion of the corn harvest, that crucial moment when the staple crop must be gathered, processed, and stored to sustain the community through winter. The focus on corn harvest appears in multiple Native American moon naming systems, though associated with different months depending on regional climate and growing seasons. These diverse names remind us that while we all observe the same moon, the meanings we attach to it arise from our particular relationship with the land, climate, and seasonal patterns where we dwell. The hunter's moon name that dominates English language usage represents just one thread in a rich tapestry of human moon observation spanning cultures and centuries. For those inspired to observe the hunter's moon, whether this October or in future years, several practical considerations can enhance your viewing experience. Unlike specialized astronomical events requiring telescopes or particular locations, observing the full moon requires nothing more than your eyes and a clear view toward the horizon, making it one of the most accessible celestial observations anyone can enjoy. The timing of moonrise varies with your latitude and longitude, so checking a reliable source for your specific location ensures you don't miss the moon's appearance over the horizon. The moment of moonrise, when the lunar disk first breaks the horizon line, offers the most dramatic viewing opportunity. This is when the moon appears largest due to the moon illusion we discussed earlier, and when it often displays its most striking colors. Atmospheric scattering gives the rising moon rich orange, amber, or even deep red hues, creating the phenomenon some traditions called the blood moon. These colors fade as the moon climbs higher and you observe it through less atmosphere. Finding a location with a clear view of the eastern horizon improves your moonrise experience significantly. Urban observers might seek out hilltops, tall buildings with eastern views, or waterfront locations where the horizon remains unobstructed. Rural observers often have easier access to open horizons but should still scout locations in advance if possible. The presence of foreground elements like trees, buildings, or landscape features can actually enhance photographs of the rising moon, providing dramatic scale and context that emphasize the moon's apparent size through the illusion effect. Weather obviously plays the crucial role in any astronomical observation. October weather in many northern hemisphere locations proves variable, with autumn storm systems potentially obscuring the sky. However, October also brings many clear, crisp nights with excellent visibility. Some observers find that timing their viewing for the nights immediately before or after the exact moment of full moon provides similar visual rewards with potentially better weather odds. The moon appears nearly full for about 3 days surrounding the actual full moon moment, rising just minutes apart on consecutive evenings during the harvest moon and hunter's moon periods. For photographers, the full moon presents both opportunities and challenges. The moon's brightness can easily overexpose images if you use camera settings appropriate for the dark night sky. Instead, treating the moon as a sunlit object and using relatively fast shutter speeds prevents this overexposure. Including foreground elements requires balancing the bright moon with the much dimmer landscape, often best accomplished by taking multiple exposures and combining them later, or by waiting for the moment shortly after moonrise when the sky retains some twilight brightness. Modern smartphone cameras increasingly handle these challenging lighting conditions automatically, making full moon photography more accessible than ever before. Paradoxically, while the full moon provides spectacular viewing for its own sake, astronomers who observe the moon's surface features prefer other lunar phases. During full moon, sunlight strikes the lunar surface nearly straight on from Earth's perspective, eliminating the shadows that reveal craters, mountains, and valleys. The moon's surface appears somewhat washed out and flat under this direct illumination. Observers interested in lunar topography prefer the quarter phases or gibbous moons when shadows cast by mountains and crater walls create dramatic relief visible even through small telescopes. The full moon's glory lies in its brightness, its visual impact, and its cultural significance rather than in surface detail. And on that note, as October's hunter's moon traces its ancient path across the autumn sky, it connects us to countless generations who watched this same celestial dance, marking seasons, planning harvests and hunts, and finding meaning in the reliable rhythms of the heavens. Whether you observe it for its beauty, its astronomical significance, or simply as a peaceful presence in the night sky, the hunter's moon continues its eternal vigil. Thank you for joining me on this exploration of October's full moon. Until next time, may your skies be clear and your nights be peaceful.